I'm teacher of the year for some reason. We want to put that in base 2. So how do I make 8 base 2? 2 cubed. Okay, so I get log base 2 of 2 to the 3rd power. How do I put 16 in base 4? 4 squared. So now when you do that, this portion here cancels, leaving you just 3. Minus comes down. This portion right here cancels each other out, leaving you just the 2. So you get 3 minus 2, which is just 1. Yeah. If these were the exact same base, yes. But I like your thinking, but just make sure it's the same base if you do it as a fraction. Any questions on number 1? Everyone feel you're going to get number 1, like that kind of problem, correct on the test?
So wait, what are those cancel out?
Because log base 2 of 2. So let me just take this little section here. Log base 2 of 2 mathematically is the same thing as log 2 over log 2, which becomes 1. That's all. And then the exponent just comes floating down. It's like, dude, I'm now a base. Okay. Or you could say this, that log brings the exponents down front. This becomes 3 times 1, which is 3. This becomes 2 times 1, which is 2. Subtract it. We good? A-okay? Life's good? All right. Moving on. All right, log base 3 of 1/9 and log base 125 of 5. So I think let's take 1/9. And I know 1/9 is 9 to the negative 1 power. Hey, how are you? Good. What are you doing this? We just started on the second problem. So, do you guys agree that 1 over 9 is 9 to the negative 1 power? And if that's the case, that means that this is the same thing as 3 to the negative 2 power. Okay, because 3 squared is 9. So I'm going to take this, plot it in there. So I'm going to get log base 3 of 3 to the negative 2 minus... So let's think about this log base 5, or log base 125 of 5. Any thoughts? Yeah. Ooh, you are so close. 125 to the 1/3. Do you see why it's not negative 3, it's 1/3? Yeah. Okay, so 5 is the exact same thing as saying the 3rd root of 125. Do you agree with that? It's 5 times 5 times 5. And that means that 125 raised to the 1/3 power is going to be the same thing. So if I plug this back in for 5, I'm going to get minus log base 125 of 125 to the 1/3 power. So theoretically, the exponents could drop down front. This is the same thing, becomes 1. So I get negative 2 minus, this cancels out. Exponent comes down, minus 1/3. Negative 2 minus 1/3. We're going to go more negative. So we're going to get an answer of negative 2 and 1/3. Or you could change it to negative 7/3. Or you could change it to negative 2.3 repeating. Things like that. I would keep it as a fraction, but if you gave me a repeater, I'm not going to be too up in arms about that. What do you think? So that one's kind of a puzzle because you have to think through. And I would say that would be definitely a problem that you would not, the first 2 problems you would definitely have on the non-calculator portion, non-graphing calculator portion. So if you have the one that adds, subtracts, multiplies, and divides, great. You can use it on there. It's not going to necessarily help you out with this problem. But just please know that. Are we okay on the first 2? Can I move forward? No? Yeah. See you soon. I'll have this recorded for you, okay? Good luck at the orthodontist. And they don't like it when you bite your fingers. Or their fingers. See you tomorrow, bub. Wave your camera on your way up. Yeah, there you go. All right. Can I go to number 3? Number 3? What happened?
His face got so red when he started talking to him.
He's the greatest kid in the world. I love that kid.
He's like, my world is all right. You never cheat. Yes, I do. We
I have haven't said any names yet.
Sometimes I have to know what to do. Oh, wow. We laughed at it.
That's why I record. There's just raw footage. All right. Ready? So, some ways to think about this problem. A couple things. If you're talking, you're being rude. So, I have taught you that you could do this, and then you can do the snail method, and you're like, oh, okay, that's 3 raised to the x is equal to 0. And you still want to solve for x, so then that becomes a tough thing to think about, because can I raise a number to another number and get 0? I know 3 raised to the 0 power is 1. If I raise 3 to a negative number, I might get close to 0, but I'm not going to get there. So what do you think this answer might be?
Undefined.
It's not defined. Undefined. Undefined. Okay? So if you have natural log or log, and there's a 0 involved as that natural log or log, it's undefined. Doesn't matter if the whole rest of the problem can be done. If you have a portion of a problem that's undefined, the whole rest of the problem is undefined. Okay? Can I move on? I know Grotto got this one. He plugged in his calculator. You get 2.6 roughly?
Yeah, I got negative. Or not, I don't know.
You got 0? Someone else get 0? So we just plug it in your calculator. Somebody get 0? Perfect. Okay, so somebody asked me earlier, hey, can I do the snail method when it's natural log? Absolutely. What you have to remember is log base e of 1 is equal to x. So I could rewrite natural log as a log. If I do the snail, e raised to the x power is equal to 1. Well, what does e have to be raised to in order to get 1? What does any number have to be raised to get 1? 0. So I'm going to solve this problem to be goose egg. Okay. Do I have to use the snail method? No. Okay. Will you see a natural log or a log of 0 or of 1? Yes. 3? Undefined. Lindy. Number 5. So, problem number 5. I would say let's condense it. If I condense it, I'm going to get log base 4 of 12.8 times 5. 12.8 times 5. Whoops. 12.8 times 5 is 60. So, 64. Thank you. 64. So how can I make 64 in base 3? Or excuse me, base 4. 64 is 4 to what power? 64 is 4 to what power? 18 is not right. 4 to the 4th is 256. To the 3rd. So I get log base 4 of 4 to the 3rd power. That becomes 1. The exponent comes down front. So my answer to this one's just 3. Can I go on? Now? 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 What about now? What about now? What about now? What about now? Yeah? Sweet! Alright. If this was on the non-calculator part, that would tell me that 343 definitely can break down to base 9. So 9 to the 1st is 9, 9 to the 2nd is 81, 9 to the 3rd. Huh? 9 to the 3rd is 729?
It's 240. It is. He told me it was 240.
9 to the 3rd is 729?
Yes.
Oh. Okay. Yeah, dude, we're trying to tell you. You don't want to listen. You act like you're talking to your wife or something. All right. So 9 to the 3rd doesn't work. I'm sorry. I told you guys wrong over here. So how's another way I should approach this? No, not calculators. How can I do it without a calculator? What's that? Whoa! Shh. Here we go. So this is definitely one of those problems. I'm going to make it equal to x. Still with me? What am I going to do now? Got to do the snail. So I get 9 raised to the x power equals 243. So let's investigate this. I already know. I know I can't do 9 and 243 to be the same base. So let's break 9 down to a smaller base. What's a smaller base that 9 breaks down to? 3 to the second. So this is the same thing as 3 to the second, so I get that. All right, is that okay?
Yeah.
Now, 243, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3. So 3 to the 5th power is 343. I have the exact same bases. What do I do with the exponents then? Set them equal to each other. So I get 2x is equal to 5. So x is equal to 5 over 2. X equals 2.5. X equals 2.5. You pick your fave. Some of you are talking too much. Well, I knew this would be on the non-calculator part, so I had to trick it around. I knew that I could break 9 down to 3 squared. Just to think maybe I could get to 243. So I couldn't get to 243 going 9 times 9 times 9, because that was 729. Even though, I made a mistake earlier saying it wasn't. So what? Who? Stop talking about her.
Just because we're talking doesn't mean it has to be about you.
I don't like it when people whisper about me.
Just because we're talking doesn't mean it has to be.
Hey, so if you guys are talking gossip, you gotta fill me in.
Alright.
Yeah, honestly, why do you call me Ewell? That's what I want to know. That is.
I'm still recording, so watch any of the terminology that's going to come out. You start dropping F-bombs, you gotta do traction. Alright, so stop talking about her, she's getting paranoid. And then if she starts crying, you guys are in trouble. Santa won't be coming. Alright, number 7. Natural log and E are inverse operations of each other, right? So what's the answer?
The answer is
Yeah, that cancels out, so I get x plus 6 and we're done. It's not equals, it's just whatever the exponent would have been. Is that right? May I move on?
why not?
So natural log and E cancel each other out. They're the key to unlock. The key and unlock. They unlock each other.
What exactly is E?
E is called the exponential.
Is it like 2.7 or something?
It's approximately, yeah. It's the summation of this math equation that's like from me to you and then 10 times further.
What's the
Yeah.
point of-
Are you going to take the packet for
Why is that?
Let's see. I'm going to work out each and every problem. Sure. For you, I will.
Actually, just for me?
Just for you.
Okay.
And
Wait, so is it
Nobody else, though.
is the next I can't tell if you're being serious.
So let's fill you in. Let's see. I will go through and do all the work on this packet, and then you will get credit for it. I think that's called plagiarism.
Well, what if I...
Or
I was just trying to get more points in the grade point. That's why.
Okay, for you, I'll put more grade points in for you. I'll just put, find an arbitrary thing and put points in. Don't worry. It's the least I could do for you.
No, you're being so sarcastic.
I know.
It's a simple question.
All right.
Is it 81?
It is 81. Awesome. E and LN, they knock each other out. These are gone. Done. Okay. Will you all work on 9 through 12? 9 through 12. 9 through 12. And in about 3 minutes, we'll look at 9 through 12. Let's run through these. I want to find the inverse of both. So first thing I'm going to do is let's find the domain. I can plug any number I want. I can plug any number I want into x and get something out. Now, it might be a fraction and it might be 1, and that's totally fine. As far as my range goes, remember this. If we went back here on this kind of problem, or even this kind of problem, it's just I can't get to a 0 when I plug values in. Okay? No matter what number I plug in, this is not going to become 0. No matter what I plug in here, this is not going to become negative. So my range is going to go from 0, open or parenthesis, going to infinity. So that's my domain and range of my original. Okay? It's important that you find that first. Then I'm going to start finding the inverse. So I'm going to do this. I'm going to change functional notation to y. Still with me? All right. Flip-flop x and y. Just change the spot of them. Once I've changed the spot, theoretically, these are flip-flopping as well. Okay? But I don't want to say that's always the truth. So now let's solve this. I could go through this a couple of different ways. I can snail it, going like this. So that would give me log base 3 of x equals y. Log can't be 0. Log can't be negative. So this is my inverse here. The domain of this being that a log of whatever can't be negative, log can't be 0. My domain has to go from 0 to infinity. But then my range, think about my range. Being I can't plug any numbers, I have to plug numbers bigger than 0 in. What would happen if I had log base 3 of a decimal? Is it negative? Right? If this was a really small decimal between 0 and 1, do I get a negative result out? The answer is yes. So my range does indeed go from negative infinity to infinity. So that's my inverse of that first one. May I move on? Holding on. Good? Second problem. So I'm going to take a look at it. I want to find the domain and the range of the original. So if I plug any values into here, if I get plugged like negative numbers into this, this is just going to be a small little value, but this minus 4 means something. So if I plug a number in, I can plug any number I want in, negative to positive infinity, including 0. So my domain is going to be this, negative to positive infinity, while my range, so can I get, if I plug a number in for x, can my answer come out to be negative? Can I get a negative answer? Yeah, that negative 4, the minus 4 means something. So my range is going to go from negative 4 to infinity because of this. Now let's change functional notation to y equals flip-flop x and y. Let's solve for y. So I'm going to add 4. Now, some of you asked at this point, where should I go? Can I snake it or snail it? The answer is yes. Make sure that's in parentheses if you snail it and do this. Okay, actually it goes this way. Sorry about that. So then I'm going to get log base 5 of x plus 4 is equal to y plus 1. Get y by itself. The domain of that, can I get any negative values that I plug in here? Can I take a log and get a log of a negative? No. Can I do a log of a 0? No. What number is going to be the smallest value I can possibly plug in to where this doesn't become 0 or negative? Negative 4, rounded bracket. And then my range, if I had this coming a decimal between 0 and 1, I'm going to get a negative value, so my range is going to go from negative infinity to infinity, which just happens to be that we flip-flop the 2. Okay, so log base. Someone might have asked this as well. What if I had this for an answer? What if I had y equals log x plus 4 over log 5 minus 1. That's also the inverse. It's just in change of base form. It's your choice which way you want to have it. Can I move forward? And again, it's being recorded so you can watch this later if you need to. Okay? Can I do the log of 0? No. Can I do the log of a negative? No. My domain is going to go from 0 to infinity. My range, if this value here is a decimal between 0 and 1, I get a negative value, so I get negative infinity to infinity for a range. Flip-flop, or take it out of functional notation. Flip-flop x and y. And solve it. So this comes x over 2. Is that okay? Can I do that? Is that okay so far? And I could have brought that exponent back up top. Kind of which way you want to go with it, I don't know. So from here, this is log base 10. So I'm going to go 10 raised to this and 10 raised to this. So that's going to give me y is equal to 10 raised to the x over 2. I saw that some of you had 10 equals square root of 10 to the x. That's also correct. So it's your choice if you want to do that or this. Again, can I plug negative values in for x here? Yes. No matter what I do to this, though, I can't get a negative value out. Can I get 0 out? No. I can get close to it. Yeah. I could have. Absolutely. So going this way. Like that. And then 10 to the 10 to the, so 10 to the x is equal to y squared. If I take the square root, same thing as the 1/2 power, right? 1/2 power times x is that. So it's your choice which area you want. Both. X over 2 is my exponent.
You will.
All right, almost done. Last one. See if we work through this one real quick. Domain, smallest value I can plug in is -2 to infinity. Range, if I make this become a decimal between 0 and 1, negative to positive infinity. Okay, I could bring the exponent up front if I wanted to, or I could do this, make that an x, so I'll make that x, make that y, and that's going to give me log y plus 2, 10 raised to the, and 10 raised to the, because that's log base 10. So 10 to the x over 6, negative 6, excuse me, equals y plus 2. So my answer is 10 to the x over negative 6 minus 2. Again, my domain looks like I can go negative to positive infinity. My range, no matter where I plug in, I can get a negative. The smallest negative I can get is probably -2. Have a great day. Bring this back tomorrow with you, please. It does not have to be done.